In this lesson, we're going to review solving radical equations. So when we talk about solving radical equations, this is an equation with a radical involved somewhere. So you might have a square root somewhere, a cube root, a fourth root, a fifth root, so on and so forth. So the way we undo a square root is by kind of squaring both sides. The way we'd undo a cube root is by cubing both sides. A fourth root, we'd raise both sides to the fourth power, so on and so forth. But there's a kind of problem that comes up when we work with radical equations. To see what I'm talking about here, let's look at a simple example. Suppose you had something like x equals a number. In this case, we're just going to let that number be 10. If I squared both sides, so that would give me x squared is equal to 100. Notice how this new equation has more solutions than the original. So what do I mean by that? Well, we know from the last section where we talked about solving quadratic equations that x squared equals 100 can be solved by the square root property. This would be x is equal to plus or minus the square root of 100, which is 10. So this basically is x is equal to 10 or x is equal to negative 10. Okay, well, 10 works as a solution to the original equation. If I plug in a 10 for x there, I get 10 is equal to 10, which is true. That works. But if I use negative 10, let's say I plugged in a negative 10 there, negative 10 does not equal 10. This is false. Okay, this is false. So what happens here is that when we squared both sides, we lost a little bit of information. Okay, we don't know whether it was 10 that was squared or negative 10 that was squared, because 10 squared is 100, but also negative 10 squared is 100. So we don't know which was squared. So this guy right here, this x equals negative 10, is an extraneous solution. Okay, that's what we call a solution to a new equation, okay, that was formed that doesn't work in the original. Okay, so that guy is extraneous. So to guard against this, what happens is we have to check all of our proposed solutions when we're working with radical equations. All right, so for solving radical equations, the first thing you want to do is isolate the radical on one side of the equation. Then you're going to apply the power rule. So that just means if it's a square root you isolated, you raise both sides to the second power. If it's a cube root, you raise both sides to the third power, so on and so forth. So the next step is if a radical remains, you're going to repeat steps 1 and 2. So you're going to have to isolate again. And then again, if it's a square root, square both sides. If it's a cube root, cube both sides, so on and so forth. So once we've kind of dealt with all the radicals, we're going to solve the equation. Then we're going to check all potential solutions. So this guy is very important because, again, we want to guard against extraneous solutions. All right, let's take a look at the first example. So we have the square root of 10x plus 1 is equal to 9. All right, so in this particular case, my square root operation is already isolated on one side, and I just have a number on the other. So essentially, I just want to square both sides so I can clear that square root operation. Okay, so we have square root of 10x plus 1 is equal to 9. I'm just going to square both sides. We know that this index of 2 here cancels with this exponent of 2. So we know that the square root operation is basically gone, and I just have my radicand, which is 10x plus 1, and this equals, I've got to square this side as well, so this is 81, okay? So another way to think about this before I go further, remember you can always write this in exponential notation. So if you're struggling, you can say this is 10x plus 1 raised to the 1/2 power, and this is equal to 9. Okay, I haven't done anything illegal. I just wrote the square root of 10x plus 1 as 10x plus 1, that quantity raised to the 1/2 power. So now if I use the power to power rule here, it becomes very clear. 1/2 times 2 is basically 1. So this guy right here becomes an exponent of 1. So that's how I know I'm getting my 10x plus 1. Okay, so if it's not clear for you, by doing it in that way, you can always use exponents to make it a little bit cleaner. All right, let's scooch this up. And let's just solve this equation. So let's subtract 1 away from each side. This gives me that 10x is equal to 80. I want to divide both sides by 10 so that I can isolate my variable x. And so we know that this would cancel with this, and I get x is equal to 80 over 10 is 8. Okay, so this is my proposed solution here. X is equal to 8. We need to check, again, to guard against errors. So if I plugged in an 8 there, I would get 10 times 8, which is 80, plus 1, which is 81. So we would have the principal square root of 81 is equal to 9. That's 9 equals 9. So this guy does check out. So x equals 8 is the correct solution. All right, let's take a look at another one. So suppose we saw x is equal to 2 plus the square root of x minus 2. So again, the first thing I want to do is isolate the radical on one side of the equation. So that square root of x minus 2, I've got to isolate that. How can I do that? Well, I've got this 2 that's being added to it. So I'm just going to subtract 2 away from each side of the equation. We know this would cancel. On the left side, I would have my x minus 2. This is equal to, I'm going to have my square root of x minus 2. Okay, so now that I've isolated the radical on the right-hand side, I can square both sides to clear the radical, okay? But I've got to be careful here on the left. This is the quantity x minus 2 squared, okay? We haven't talked about this in a while, but again, a common error is for students to just say this is x squared minus 2 squared. That is wrong. Please don't do that. Remember, this is a quantity x minus 2 squared, so I have to go x minus 2, that quantity, times x minus 2, right? But again, we all know at this point we can use our special products formula. So I would square the first guy, which is x, so that's x squared, then minus 2 times this guy, which is x, times this guy, which is 2, so that would be minus 4x, and then plus this guy, 2, being squared, which is 4. Then this is equal to, if I squared the square root of x minus 2, I would just get that x minus 2. Okay, let's scroll down and get some room going. We'll come back up. So now I want to solve this guy. So let's go ahead and clean it up. Let's subtract x away from each side of the equation, and that's going to cancel. Let's add 2 to both sides of the equation, and that's going to cancel. So on the right, I know I'm going to have 0, right? On the left, I'm going to have that x squared minus 5x, right? Negative 4x minus x is negative 5x. And then plus 4 plus 2 is 6. Okay, so this is equal to 0. Now I can solve this with the quadratic formula. I can solve it with factoring, whatever you want to do. Factoring is a little bit easier here. So let's go ahead and set this up as x and x. This equals 0 over here. So what are my two missing kind of items here? I need 1 there and 1 there. Well, you need two integers whose sum is negative 5 and whose product is positive 6. So that would be negative 2 and negative 3, all right? So now I can use my zero product property, and I can set each factor equal to 0. So I'm going to set x minus 2 equal to 0. Then I'm going to set x minus 3 equal to 0. And to solve this guy on the left, I would just add 2 to both sides of the equation, and we get x is equal to 2. To solve this guy on the right, I would add 3 to both sides of the equation, and we get x is equal to 3. So these are our two proposed solutions. So let's copy this, and we're going to check. All right, so if I plugged in a 2 for x here and here, what would I get? I would get that 2 is equal to 2 plus the square root of 2 minus 2 is 0. So basically, this is just 2 equals 2. So this guy is going to check out. If I plugged in a 3 for x, so there and there, you would get that 3 is equal to, you have your 2 plus the square root of 3 minus 2 is 1. Square root of 1 is 1. 2 plus 1 is 3. So 3 equals 3. That does check itself out. All right, let's look at a harder example. So suppose we have the square root of 2x minus 2 minus the square root of 8x plus 1, and this is equal to negative 3. All right, so the idea here is that I've got two square roots. I've got to isolate one of them first, square both sides. Then I'm still going to have a radical, so I'm going to have to do it again. So this is just a more tedious problem. All right, so let's go ahead and add the square root of 8x plus 1 to both sides. And what I'm going to have here is that the square root of 2x minus 2 is going to be equal to, you'll have the square root of 8x plus 1 and then minus 3, okay? So now I'm going to square both sides. This guy right here, I'm just going to have my 2x minus 2. This is equal to, again, you've got to remember, when you square this guy here, it's got to be expanded. Okay, so you could use FOIL or your special products formula. It doesn't matter, but you can't just distribute the exponent to each term there. Okay, don't do that. So if I squared the square root of 8x plus 1, I would get 8x plus 1. So that would be the first guy there. Then you have a minus here, so this would be minus. You're going to have 2 times this square root of 8x plus 1, and then times the 3. So 2 times 3 is 6, so let's just put a 6 there. Then plus the last guy here, 3 squared. Okay, let's scroll down and get some room going. All right, a lot to clean up here. So I know that 1 plus 9 is 10. So let me just write this as 10. And let me go ahead and subtract 10 away from each side of the equation now. So that's going to cancel. And let me subtract 8x away from each side of the equation. So that's going to cancel. On the left side, 2x minus 8x is going to be negative 6x. Then negative 2 minus 10 is minus 12. And this is equal to, you've got your negative 6 times the square root of 8x plus 1. Now, you have a number, which is negative 6, that is multiplying your radical. At this point, you can square both sides as it is, but to make it simpler, we're going to divide both sides by negative 6. Okay? All right. So we know that if we divide like this, we can split this up and say this is negative 6x over negative 6. And I could say plus negative 12 over negative 6, just to make that a little simpler. So on the left-hand side, I would have x and then plus 2, right? Negative 12 over negative 6 is 2. And this is equal to, this cancels, so I just have my square root of 8x plus 1. So now to clear this radical, I'm just going to square both sides of the equation. So I'm going to square this side, and I'm going to square this side. So the quantity x plus 2 squared, again, I've got to use my special products formula or use FOIL or whatever you want to do. Just don't distribute the exponent to each term. Okay, that's wrong. So this would be x squared plus 2 times x times 2, so 4x, and then plus 2 squared, which is 4. This is equal to, if I square this guy, I would get 8x plus 1. Okay. So now let's clean this up. Let's subtract 1 away from each side of the equation. That's going to cancel. Let's subtract 8x away from each side of the equation. And that's going to cancel. So I'm going to have that x squared minus 4x plus 3 is equal to 0. So again, I can solve this guy with factoring, or I can solve it with the quadratic formula, whatever you want to use. Probably easier to solve it just with factoring. So let's go ahead and put this as x here and x here. And 2 items that I'm missing here, those numbers would sum to negative 4 and give me a product of positive 3. So that would be negative 3 and negative 1. Okay? So now I can use my zero product property to get a solution. We'd have that x minus 3 is equal to 0, or x minus 1 is equal to 0. So if I solve this guy here, I add 3 to both sides of the equation. I get x is equal to 3. If I solve this guy right here, I add 1 to both sides of the equation. I get that x is equal to 1. So x equals 3 or x equals 1. So we're not done. We need to check these. So let's check x equals 3 first. So I'm going to plug in a 3 there and there. So 2 times 3 is 6. 6 minus 2 is 4. Square root of 4 is 2. Then minus. 8 times 3 is 24. 24 plus 1 is 25. So the square root of 25 is 5. So is 2 minus 5 equal to negative 3? Yes, it is. So that checks out. If I plugged in a 1 for each occurrence of x, what would I get? 2 times 1 is 2. 2 minus 2 is 0. So that's gone. 8 times 1 is 8. 8 plus 1 is 9. So you would have the negative square root of 9. Square root of 9 is 3. If I put a negative out in front, it's negative 3. So negative 3 equals negative 3. So x equals 1 checks out as well. All right, now let's look at 1 with an extraneous solution. Okay, so this guy right here, you're going to have a problem. So we have the square root of 7x plus 2 is equal to negative 3 minus the square root of 3 minus x. Okay, so on the left-hand side, this square root operation is already isolated. So let's get things started by just squaring both sides. So I have the square root of 7x plus 2. I'm going to square this side. And then I'm going to square this side. So negative 3 minus the square root of 3 minus x. Again, squared. On the left, I'm just going to have my radicand, which is 7x plus 2. on the right, again, I've got to use my special products formula. So I'm going to go ahead and square this guy right here, this -3. So that's going to give me a +9. Then minus, you've got 2 times, you've got your -3, and then times the square root of 3 minus x. So -2 times -3 is 6. So let's put +6 there. And then times, again, that square root of 3 minus x. Now you have to be careful when you use this when the first term is negative, okay? We always account for this sign right here. If it's positive, then you get a positive there in the middle term. If it's negative, you get a negative there in the middle term, okay? But in this case, we have a negative as the first term, and you don't usually see that when you're working with these kind of sample problems, okay? So you have to account for this negative. So that's why we have a positive here, because we ended up with a negative times a negative. That gave us a positive, okay? So make sure you understand that. All right, then plus, we've got this last guy squared. If I squared the square root of 3 minus x, I would get 3 minus x. Okay, so let's clean this up now. We would have 9 plus 3, which is 12. Okay, so this is 12. If I subtract 12 away from each side of the equation, I would have 7x plus 2 minus 12 is -10. So you put plus -10 or -10, whatever you want to do. This is equal to, then I'm going to add x to both sides of the equation. And we know this is going to cancel over here. 7x plus x is going to be 8x. So let me erase this and just put 8x here. So then I have on the right-hand side just my 6 times the square root of 3 minus x. Now at this point I can square both sides, but it might be a little easier if I kind of divide both sides by 6. You're not going to get whole numbers, but I find it to be easier to work with smaller numbers, even if they're fractions, okay? So I'm going to divide both sides by 6. On the right side, I'm going to have the square root of 3 minus x. On the left side, you think about 8 over 6, that's 4/3, times x. And then I'm going to put plus. You have -10 over 6. Let's put minus 5/3, okay? Now, I'm going to square both sides. So I'm going to square both sides. So to use my formula, I'd square 4/3 x. So that would be 16/9 times x squared. Then this guy would really be a minus here, right? I wrote plus negative, but it's really a minus. So let's put a minus out in front. You have your 2 times the 4/3 x times the 5/3. Okay? So if I go through and multiply that, you have 2 times 4, which is 8. 8 times 5, which is 40. So this is 40 in the numerator, over 3 times 3, which is 9 in the denominator. Then plus, you're lastly going to have 5/3 squared. 5 squared is 25, and then 3 squared is 9. Okay, so this is equal to, over here, the square root of 3 minus x being squared is just 3 minus x. So now, what I want to do, to clean this up, I'm going to multiply both sides of the equation by 9. So if I multiplied these guys by 9, this guy right here, this guy right here, and this guy right here, the denominators would just be cleared, right? So you'd have 16x squared minus 40x plus 25. This equals, I've got to multiply each term here by 9. 3 times 9 is 27, then minus 9 times x is 9x. Okay, so let's clean this up. If I add 9x to both sides of the equation, that'll cancel. And then if I subtract 27 from both sides of the equation, that'll cancel. Okay, so on the left-hand side, I just have my 16x squared. And then negative 40x plus 9x would give me negative 31x. And then 25 minus 27 is minus 2. And this equals 0. Okay, so I'm going to solve this using my quadratic formula. And so basically, let me scroll down a little bit. I know that this 16 is my value for A. The negative 31 is my value for B, and the negative 2 is my value for C. So x is equal to the negative of B. B here is negative 31, so that's 31, plus or minus the square root of B squared. If I squared negative 31, I would get 961. Then minus, you've got 4 times A is 16, times C is negative 2. So negative 4 times 16 is going to be negative 64. Then times negative 2 is positive 128. So you'd basically have a plus 128 there. So 961 plus 128 is 1,089. So this is 1,089. Then this is over. You've got 2 times A. A is 16, so this is 2 times 16, which is 32. Now the square root of 1,089 is 33. Okay? So this is 33 here. So this gives me two solutions. We've got that x is equal to 31 plus 33 is 64, and 64 over 32 is 2. The other solution is 31 minus 33, which is negative 2 over 32. So negative 2 over 32. Each is divisible by 2 there. This would be a 1, and this would be a 16. So let's go ahead and check these. Okay, so let's start out by checking x equals 2. So if I plugged in a 2 there and there, what would I get? Well, 7 times 2 is 14. 14 plus 2 is 16. The principal square root of 16 is 4. This equals, over here, we'd have a 2 for x, so 3 minus 2 is 1. Square root of 1 is 1. So you'd have negative 3 minus 1. Negative 3 minus 1 is negative 4. That does not work out. 4 does not equal negative 4. This is false. So go ahead and mark this one off. Okay, that's not a solution. That one is extraneous. Then let's try negative 1/16. Okay, so we're going to plug that in. So here and also here. So this one's going to be a bit messy. So 7 times negative 1/16 is negative 7/16. Then plus 2. I get a common denominator here by multiplying 2 by 16 over 16. So that would be 32 over 16. So negative 7 plus 32 is going to be 25. So what I'd have here is I'd have the square root of 25 over 16, which basically is 5/4. Okay, so that's my left side. On the right side here, if I have 3, let me kind of slide this over. If I have 3 minus, again, negative 1/16, so I can put plus 1/16. Well, what's going to happen is I need to get a common denominator, so I'll multiply this by 16 over 16. 3 times 16 is 48. So you'd have 48 plus 1, which is 49. So this is 49 over 16. So the square root of 49 over 16 is 7/4. Okay? So you'd have negative 3 minus 7/4. To get a common denominator here, let me multiply this by 4 over 4. So this would be negative 12/4. So I ended up with negative 12 minus 7, which is negative 19 over 4. So we can clearly see that this one doesn't work out either, okay? This is also an extraneous solution because 5/4 does not equal negative 19/4, right? This is false. Okay, let me make that A a little bit better. So in this particular case, you do not have a solution for your equation. You can go ahead and just mark this as no solution. No solution.